Now, here's sort of an interesting question. If everything's receding away from the Milky Way, does that make us at the center of the galaxy? Okay. So the recession of distant galaxies often leads to the misconception that the Milky Way is the universe's center. Are we at the center of everything? No. We need to sort of think of the fact that we're on a balloon and we're seeing everything on the balloon. However, because space is expanding no matter where we are located, galaxies all move away from you. There's no preferred center.
Do you have a stand for the...
So this is an odd thing to think that there's sort of no center to, I mean, if you've got a balloon, you'd think there's a center to the balloon, but you're actually on the surface of the balloon, and somehow you're looking through the surface, and it actually leads to a question, is space curved? Is it flat? Is it, yeah, we're not going to go there too much, I think, but yeah, that leads to an interesting concept, doesn't it? Okay. So this leads to something interesting concept called Olbers paradox. In 1823, Heinrich Olber, sounds like a German name, offered Olbers paradox. If the universe extends forever and has existed forever, some people think that the universe is infinite. This is kind of the explanation why we can say the universe is not infinite. The night sky should be bright, but of course it isn't. It's dark. Because if it extends forever, every time you look, you see, he reasons that no matter which direction you look in the sky, you would see light. But you know, we see darkness when we look up at space, a lot of darkness. And so if the universe was both infinite and the universe had been here forever, then everywhere we look, we would see stars. So and the night sky would be bright. And of course it's not. It's dark. And so that kind of helps us to understand a lot of what we're talking about. Okay? So to kind of tie up Olbers' paradox, so that gives a finite age and the speed of light means only a finite volume of starlight is available. Because we see, well, it's dark. The world is dark. Okay. Now, how do we also know this? A very, very important experiment was done, or discovery was made, I should probably say. Something called the cosmic background radiation, or cosmic microwave background. If indeed the proposed very dense early universe implied it must have once been very hot, perhaps 10 trillion Kelvin. That's just unbelievable how hot that is. It was proposed as the universe expanded and cooled, the radiation that existed would survive to the present as microwave radiation. So the theory was there would be this microwave radiation. Remember, we learned about what microwave radiation is in the universe. Okay, and it's called the cosmic background radiation. Well, in 1965, it was discovered. They actually theorized it would happen, that it existed beforehand. And then these two guys, Penzias and Wilson, in 1965, discovered it. Accidentally, actually. Interesting thing. They were, I forget the exact story, but it's something like they were, I don't remember. I've seen this. Anyways, they accidentally discovered it. There's a kind of a cool story on it. I can't remember how they did. And they discovered the cosmic microwave background radiation. I think they won the Nobel Prize for it. It was a big deal in the world of astronomy. Big deal. All right. So here's another picture of the concept of space expanding here. Here we have two. Here's picture one. This is in the past, maybe, and this is the present right here. Okay, and so it was warmer in the past, so we have the wavelength here of light, and so it's blue. Blue light would be higher in temperature or higher in energy, and now we have red light because it's now further apart. So the space expands and stretches. The light waves moving through it increase their wavelength because this is in the past, and now the box is expanded. These are the same two galaxies, you know, and now they're further apart, and now we have cooler, or you know, and so that we found this background radiation out in the sky. And here is actually the graph of cosmic wavelength, the brightness and the wavelength. And it's not very many, but it follows a perfect black body with a temperature about 2.72 Kelvin, and they actually predicted about 3 Kelvin, but it's very cold, but it's still something there. That's what kind of has got the background heat in the entire universe. All right. This led us to the concept of the current theory suggests that the early universe consisted of protons, neutrons, and electrons. Okay, but the initial hot dense state allowed nuclear reactions to create helium. Based on the estimates of the early universe's expansion rate, about 24% of the matter should be transformed to helium, in a good agreement with what is observed in old stars. In old stars, we see lots of helium, so that's an interesting thing. So one of the things about the oldest stars that we can see, all right, is that we find the right ratio, and that helps us to understand. Helps astronomers, I should say us, I'm not really an astronomer, I'm just a teacher, helps the astronomers to confirm this. So this helps confirm some of their thoughts. Okay? So, This is kind of the introduction to the whole Big Bang and what supports it. So these are the observations that they make, and then some of the conclusions that astronomers have made as they've attempted to understand where did everything come from. Was everything at one time in a sort of the primordial atom? When that primordial atom it expanded rapidly, hence the Big Bang, and everything came to being. Now, where did that tiny little thing come from? We don't know. So those of you who might struggle with the concept of sort of origins and where things come from, I want you to understand that nobody knows where this thing came from. And again, it is also called the Big Bang Theory. New observations and measurements might change the way we view where the universe came from. But that's kind of the best estimate of the vast majority of astronomers and what we call cosmologists have right now. So I will see you in class or on the